Okay. Okay. Let me share my screen. So basically for this topic, which is stability response, the topic is not in our book. So I have a PowerPoint video for you all to see lah. I'm not sure whether you can hear the voice or not. Wait, Okay, wait Take some time to open. Okay, so basically this is our continuation topic from the PID tuning. So last time I already teach you when you increase P, I and D, what happened to your process response? Okay, so basically today I will teach you on how you can calculate the value of P, the new P, the new I and the new D. Kalau let's say you nak increase P, increase I or increase D, how you can calculate? So today I will teach you on that lah. Actually it's quite simple lah, this topic. Okay. This is can you hear my voice?
Boleh, madam.
Boleh sebab kat sini hujan. I'm not sure whether you can hear or not. Okay. So basically, if we have an unstable response like this, you nampak unstable because the response is oscillate. We call it as an oscillation lah. Oscillate, you nampak lah turun naik, turun naik, turun naik. The set point is in between. You tak achieve set point pun. So this one we can call it as an unstable response ataupun too fast response. Kalau respon yang terlalu cepat pun you akan dapat this kind of pattern lah. So basically at this response the value of PB, OKC and I is at the initial value lah. So what you gonna do? You need to improve the response by doing a tuning. So how you can do a tuning is you increase the value of PB and also you increase the value of I. You akan nampak this kind of shape lah macam kita buat hari tu. When you increase PB, the shape akan lagi move to the left and move to the right. Same goes to the I, move to the right. So how you can calculate that one? Value baru untuk PB is you kena timekan value original untuk PB naught with the 4. Same goes to I. I naught you kena time dengan 4. So you can get the value, the new value of PB and also I. So ini adalah method untuk fine tuning. Fine tuning is you come up with the value of, sangat slide ni bergerak. So bila you time with 4, that means you do a fine tuning lah to get the new value of PB and I. Bila you dapat this kind of response, you definitely tahulah you need to do a fine tuning. Boleh faham ke?
Boleh.
Boleh.
Okay. Tadi you dapat oscillate unstable response. Sekarang ni kalau you dapat the slow response. Kalau you dapat the slow response, basically this response kita ada the original value of PB and OKC and also I naught. So in order you to get the better response, you need to you nak increasekan, you nak cepatkan masa, increase the time, you need to decrease the I. Ingat lagi tak hari tu kita buat? Kalau kita decrease I, the response will shift to the left. So, yang tu kita tahu the pattern. But the value, you need to times you need to divide the PB naught over 4 and also I naught over 4. So that you can get the value, the new value of PB and also I. Macam hari tu, dalam soalan diberi value of new PB and I. You just can estimate sahaja. Sorry you can just estimate sahaja. Tapi untuk kali ni, I nak ajar you untuk you calculate the new value of PB and also I. We see the exercise. Fine tuning ni simple sahaja. Kalau you nak respon yang cepat, PB and I divided by 4. Kalau you nak kurang oscillation, PB and I time by 4. Okay, so this is the example. So basically, you nampak this one is a oscillation, the unstable response. So this response is for the pressure control. So we using the proportional control for this pressure control. So the controller setting originally is 15%. So you need to propose a new controller setting. Last time kita dapat value PB yang baru, tapi this time you kena calculate. Macam mana you nak calculate? Kalau this kind of response, you just time PB naught with 4. Then you dapat the new value of PB. So itu sahaja sebenarnya untuk hari ini. I nak make sure, I just nak explain macam mana you nak dapatkan the new value. Last time kita dah dapat values ni, dah diberi value. Ni you nak calculate. So you boleh refer to these two chart lah. Kalau you dapat in your lab, you dapat slow response, that means the PB naught and I naught will divided by 4 lah. Kalau you dapat the oscillating process macam ni, kena time PB naught and I naught with 4. Boleh faham ke?
Boleh.
Boleh.
Okay, so kita yang tu saja untuk stability response. So kalau you nak buat fine tuning memang you kena guna pakai formula tadi lah. Okay, now kita masuk ke performance analysis. So under performance analysis ni ada banyaklah subtopik. Okay, tapi yang most important thing you kena tahu about IAE lah. So IAE is integral absolute error. So why we need to do the performance analysis? Because we need to determine the optimum control. So we need to evaluate the response that we get based on the rise time, settling time, overshoot, undershoot, cycle time, and integral absolute error. So based on all these criteria, you can determine whether your process or your control system is good enough or not. Your tuning tadi tu okay ke tak? Value yang you dapat tu okay ke tak? So basically you nak evaluate based on this criteria lah. Okay. So before we go into tutorial, hari ni kita tak buat tutorial, I just nak explain on the concept lah. Okay. So for example, we have this kind of response. Okay. What is rise time? Rise time is a time taken by the process to reach the new set point. You tengok this is rise time, TR. Time taken for the process to reach new set point. So for example, we do a set point changes. So for the process to increase from set point, original set point to a new set point, the time taken is called as a rise time. So next we have a settling time. So settling time is the time taken by the process to reach stability. That means bila your graph ni, your response ni start to stable on the set point. So that one time di mana dia start stable je, kita take as a settling time. Boleh faham? So kalau dekat graph ni you boleh nampak settling time occur dekat sini lah. You nampak the response ni start to stable lah dekat set point. Dekat awal-awal ni still have an overshoot, so we cannot consider that one as a stable response. Boleh faham ke?
Boleh.
Boleh?
Boleh.
Boleh.
Okay, so next you need to know about overshoot. Okay, overshoot is a peak ataupun the amplitude. The peak of the response from the set point. So this one kita panggil as overshoot. So overshoot can be a few place yang kita put actually in one response we can have a few overshoot. Depends on the trend, on the response punya shape lah. So for this one we can see that the first overshoot, which is the highest one, OS1, and then we can have second overshoot, OS2, and lastly is OS3. Okay, next one is undershoot. Undershoot is the downward peak. Overshoot tadi upward peak. So kita punya baseline is our set point. So the upward peak from the set point is overshoot. The downward peak from the set point is undershoot. So we call it as a US lah. So we can have a few numbers of undershoot lah. This one US1, US2, US3. Faham? Boleh faham?
Faham.
Okay. So next we have a cycle time. Cycle time is the time for one complete cycle. Maksudnya, you nampak graf ni dia bentuk macam ni. Naik, turun. So that one is one complete cycle. And then dia naik lagi, baseline is at the set point lah. Naik lagi and then go downward. So this one is the second cycle. The last cycle is at C3 lah. So you have C1, C2 and C3. So ini adalah indicators yang you nak evaluate your response. Lepas you dah install the controller setting, optimum controller setting yang you buat hari tu, and then basically you need to evaluate whether your process ni okay ke tak. Ada overshoot ke tak, ada rise time you macam mana, lambat ke cepat ke, settling time you lambat ke cepat ke. So based on this indicator lah you evaluate, and then itu untuk you evaluate whether your P, PI and PID control setting tadi okay ke tak. Tapi untuk you evaluate the overall performance untuk your control system, you need to do a set point changes and also load disturbance. Dalam lab you ada buat kan load disturbance kan? Dengan set point changes.
Ada.
So you nampak kan perubahan kan bila you buat load disturbance, dia jadi macam mana? Set point changes ni. Nampak kan? So basically you boleh discuss all of this lah dalam lab you sebenarnya. Okay. You ada dapat tak respon yang macam ni, yang a bit oscillate ni? Ke you dapat a good respon je?
Ada yang
Ada
oscillate juga.
oscillate.
Yang oscillate tu sistem apa? Equipment apa? Flow ke pressure?
Oh.
Tu.
Flow
Flow.
Kalau dekat sini pressure lah, flow sometime. Flow dia tengok kepada apa ni, controller setting yang kita masuk. Kalau too low or too high, dia akan start to oscillate. Okay. So the next one is our indicator untuk menentukan performance of your control system is integral absolute error, IAE tu tadilah yang I sebut. So IAE is the sum of absolute error. So basically error we calculate by subtract the set point with the process value, process variable kan, betul tak? Before this kita tolak SP dengan PV untuk dapatkan error. Betul tak?
Betul.
So actually kalau you tengok dekat sini, we have too many error. Dekat overshoot ni ada error, dekat undershoot ada error. Overshoot pula ada 3, undershoot ada 3. So basically, what we gonna how we want to evaluate the error is we use the integral absolute error. That means we consider all the error inside one response. But we need to absolute all the error. Sebab kita tak naklah consider the negativity. Basically, the difference is only the trend. Tapi the value ni, the negativity tu, it shows the direction of the error sahaja. So negativity, it shows that the error go downward. Undershoot lah. So that's why we absolutekan all the error. That means we will get a positive error lah. So basically how to calculate the IAE is we consider the area between the curve and set point. Yang ni lah, dekat kawasan ini, semua ni, kita akan ambil area dia. So basically, in the mathematical form, IAE is equal to absolute A1, A2, area 1, area 2, area 3, area 4, sampailah. Depends kepada banyak mana area yang kita ada. Okay. So, okay, this is the example for the performance analysis set point changes for the A. So the first area that we have is A1 lah. Di mana the value of the response is start to increase. So dia ada bigger error lah daripada sini ke sini ni. Sebab dia tak achieve set point lagi. So A2 is the other one error because we have overshoot, not achieve set point yet. So that's why we take A2. And then A3, A4, A5, A6, A7. Boleh faham?
Boleh.
Okay.
Boleh.
So, the load disturbance or for the load disturbance, that means you open up your valve ke at 3 seconds ataupun you close your valve or yang itulah yang you buat kan dalam lab, open or close the valve kan, betul tak?
Betul.
Okay. So when you do you disturb the system, the response start to change lah. For this one, it start to oscillate. So when it start to oscillate and it deviate from the set point, it can contribute an error lah. You nampak lah dekat sini for the overshoot one is the area 1 lah. For the undershoot one is A2 and so on lah, A3, A4, A5 and A6. Okay, you jangan confuse kenapa dekat set point changes kita ambil error dekat A1, dekat sini tak ada. Sebabnya our new set point is SP2. Sekarang ni dekat kawasan ni dia tak achieve set point lagi. So we can consider this part error lah. Dekat sini memang we start at the same set point but the process response tak proceed and deviate from the set point lah. Boleh faham?
Faham.
Boleh.
Okay. So how to approximate the IAE? We need to calculate the area, right? So the area for this one, kalau kita nampak secara mata kasar is triangle lah. Tapi basically inside this area we have a trapezoidal punya shape. So that's why the area that we will use is area for triangle and also the area for the trapezoidal. You tahu kan? So this is the trapezoidal. The A is trapezoidal, B and also C is triangle. So for the trapezoidal, you need to plus height 1 and height 2, time with the base and time with 0.5. For the triangle, yang ni basic lah kan. And B times H divided by 2 lah. Same goes to C. B times H divided by 2. Boleh faham?
Faham.
Okay. So for example, like you do a set point change. So this is the area of A1. So under A1 pun you ada a few shape. And this one is trapezoidal, 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 and lastly is triangle. So basically you need to sum up everything lah dekat sini. Same goes to here. You need to identify lah the shape inside this one and calculate the total area. So this one is for the process response of undershoot and overshoot. You akan nampak ada region for the triangle, kiri kanan ni, and then trapezoidal. Okay, so basically the area of the total area you need to times to sum up everything lah. Kalau macam ni S1, S2, S3 sampailah Sn. Same goes to here. Semua ni you kena you kena sum up from S1 until Sn. So you dapat the total area for one area. Contohnya macam yang ini kan. Kalau you lukis lah, dia akan ada bentuk macam ni lah. Yang ni, yang ni, yang ni. So you akan ada triangle, trapezoidal, 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 triangle. So you kena total up everything. Faham?
Faham.
Okay. So ini kita ada a few type lah. Okay, basically wait So solution for figure 5.4 sector A1. You boleh dengar suara I tak?
Boleh.
Boleh.
Weh, tadi I stop
Ya.
Okay. Okay. Sorry, okay. Sekarang ni basically untuk solve this equation, kita ada a few method lah, which is type 1A, 1B, 1C. So 1A ni adalah you guna multi-base subsector, which is you assume that B1 is not equal to B2, it's not equal to B3 until Bn lah. So that one, you kena kira one by one lah, ikut kepada setiap satu shape yang ada. Type 1B ada di mana you akan dapat shape equally spaced trapezoid plus one triangle. So that means you can use this formula. You kena tengok kepada shape you. Shape you dekat sini tau. Shape you dekat sini. Sama ada equal ke tak trapezoid you. If not equal, you kena buat one by one macam this one yang atas 1A. Boleh faham?
Boleh.
Type 1C di mana your P ni kita kena rujuk kepada B ni. Shape dia sama ke tak? Kalau semua sama, that means you boleh pakai equally spaced subsector. Directly use this formula. Nanti I akan ajar you bila masa you boleh pakai multi-base 1A, 1B and 1C. Nanti dalam tutorial kita akan tengok one by one lah. Okay, this one is for 5.4 tau, yang ni. Bentuk yang macam ni. Untuk 5.5, kita ada method lain untuk kita calculate the total area. Which is first, multi-base juga, multi-base subsector. Which is you tengok setiap satu bentuk you tu, macam mana bentuk dia. So kalau macam yang ini, ada part triangle, ada part trapezoid. Okay, so depends on the shape tu lah. So type 2B pula, di mana you ada a triangle plus equally spaced trapezoid plus a triangle. Lebih kurang macam shape ni lah. A triangle, equally spaced. Yang ni not equal lah. Tapi kalau you dapat the equal one, and then you can use the 2B punya formula. 2C, equally spaced triangle and trapezoid plus one triangle. So you can use this formula. So lastly is type 2D, which is equally spaced subsector. Maksudnya sama je subsector you punya space. So you can use this formula. Based on the base tau, base you ni, you tengok lah. Kalau sama, and then you can use, depends on this condition lah, method yang ada. Nanti I akan tunjuk lah in detail. Sekarang ni I nak kenalkan you, kita ada a few method lah untuk calculate. Kita ada dua jenis figure lah, which is 5.4 ataupun 5.5. Kenapa kita ada dua jenis? You boleh tengok balik dekat atas ni. Satu dia macam naik, satu dia macam bentuk undershoot and overshoot. Yang bentuk naik ni kita refer to figure 5.4. 5.5 is for undershoot and overshoot. Boleh faham ke?
Faham.
Faham Okay. Next, we go to solution for discrete digital process response. Kita split the time equally. So So process response in digital form is obtained through the DCS and also SCADA. For calculation of area, the process response is split based on sampling time. Macam tadi yang B tu, this B ni basically for DCS and SCADA, dia akan bahagi mengikut sampling time, which is delta T ni lah. Delta T, we have T0, T1, T2 sampailah you achieve TR. This one is for the set point change. Okay, when we refer back to this graph, that's mean daripada point ni lah. Point ni sampai you achieve TR you ambil. Same goes to here. So basically, for the set point change, from set point 1, the value of PV will increase. PV1, PV2, PVN negative 2, PVN minus 1, sampailah dia achieve TR. So kita consider that part, the error at that part sahaja. Then we need to calculate the area. Same goes to this one lah. This one ni kalau let's say you decrease your set point, so you dapatlah bentuk yang menurun. Tadi you increase set point, dapat bentuk menaik. Boleh faham?
Faham, madam.
Boleh.
Okay. So for the overshoot and undershoot, sama juga. The base ni, bawah ni is in term of sampling time. Delta T1, T2, until Tn. So this value yang curve ni is your process response, PV. So this line, the middle line is your set point. Okay. So from this figure, basically, sometimes you can get the value, the data for this one. So discrete process response in table form A. So B is for overshoot and undershoot. Yang this one ni is for figure 5.6, which is your set point change. Yang B ni undershoot and overshoot. Boleh faham ke? So kalau you tengok from 0 to Tn minus 1. Okay, kita tengok from T0, Tn minus 1, the shape ni is trapezoid. So daripada table ni, we can identify that from 0 to Tn minus 1 is trapezoid. Triangles occur at Tn minus 1 to Tr. So dekat sini, triangle Tn minus 1 to Tr. Boleh faham? So at time 0, the PV value is equal to set point. Until TR, the PV value is equal to new set point. Faham ke?
Faham.
Okay. Untuk table B pula, kita tengok, kita refer our response graph ni. So you can see that from TP to T1 is a triangle. From T1 to Tn minus 1 is trapezoid. Tn minus 1 to TQ is our is triangle shape. So basically, TP occur at set point, the new set point. Okay, so basically this table ni nak tunjukkan you dekat mana data untuk triangle, mana data untuk trapezoid. Faham kan nak baca ni?
Faham.
Okay. So the last one, this part. Okay. So for figure 5.6 and 5.7, the discrete process response in graphical form. While table 1 show the process response in a discrete or digital value. So kita ada satu graphical form, satu digital value. So basically, if you get those kind of question, basically you have two method to solve that that question lah. Kalau you dapat this kind of response, so you ada two method lah, which is first type 3A, which is equally spaced trapezoid plus one triangle. You can see that at figure 5.6, table 51A, yang ni. So basically dia untuk yang ni 1A ni is an example for equally spaced trapezoid plus one triangle. So you can use this formula. Kenapa kita kata equally spaced trapezoid? Because kita rujuk kepada delta T1 and delta T2 until delta Tn. T1, T2 sampai Tn ni, the difference is the same. Base dia sama. So sama, so that's why we can choose type 3A to calculate this one lah. Faham tak? Boleh faham ke?
Faham.
Boleh.
Okay. So the other method is we have a triangle plus equally spaced trapezoid and a triangle. So bentuk macam ni lah. Undershoot or overshoot. Kita ada triangle and equally spaced trapezoid. Maksudnya delta T ni sama je semua. Kecuali delta T1 dengan delta Tn yang berbeza. That's why we kena consider this part as one triangle, this part as the other one triangle. Yang lain ni, we can assume that the equally spaced trapezoid. Okay, so we have two equation. The first one is for the change in set point. Kalau your question asking about the change in set point, then you can use this formula. If your question asking about the load disturbance, then you can use this formula lah. Faham ke?
Faham.
Faham.
Okay, tak apa, nanti I akan explain in detail lah. Kita buat tutorial nanti, baru you faham lah. So up to here boleh faham tak? Ada soalan tak?
Saya tak ada.
Tak ada, madam.
Ada, okay, good. So untuk tips ni nanti kita start buat tutorial, baru I akan highlightkan one by one lah. Okay, kalau tak ada, I think we can stop our class until here. Boleh?
Boleh, madam.
So we stop our class with Tasbih Kifarah and Surah Wal-As.